All right, here's a log graph. Everybody's favorite. Everybody loves logs. That's one thing I know. All right, so this is the original log function right here, okay? This is what we have right here, c being any value greater than 1. The subscript number doesn't go into the mapping notation, okay? So we don't need to worry about that in the mapping. We have a key point of 1, 0, and we also have not a horizontal asymptote, we have a vertical asymptote of x is equal to 0. So we're going to keep all this in mind when sketching the new graph, all right? So once again, okay, we can start by doing a mapping notation for this. So we would have x minus 1, and we would have minus 2y plus 8. The subscript 3 does not go into the mapping notation. Much like with exponential functions, the big number that's to the power of x doesn't go in the mapping notation either. So we can get our key point right away. Our key point was originally 1, 0. If we plug that in, we now have 0, 8. Now it just so happens that this actually happens to be a y-intercept as well. So we've kind of lucked out that our key point is also one of the intercepts we have to get. So that's good news. Now with the exponential functions, we could get the horizontal asymptote from the vertical translation. Well, similarly, okay, what we can do is we can get our vertical asymptote from the horizontal translation. And that will be for all log or ln functions. And the reason why is because the vertical asymptote is the y-axis, x is equal to 0, but that gets shifted left or right. And in this case, okay, it gets shifted 1 unit to the left. So we can sketch what we have so far. Okay, we have a key point of 1, 0. We have, we do not have that key point. That is my mistake. That's the original key point. We have a key point of 0, 8. So we can put that point in there at 0, 8. We have a vertical asymptote of x is equal to -1. We can put that in. And then from there, okay, we could sketch the graph, or we could get intercepts. Maybe a better idea. Okay, so I can get a y-intercept by plugging in 0 for x, and I can get an x-intercept by plugging in 0 for y. Okay, so it doesn't really matter which one you do first. Okay, I'll actually do the x-intercept first, because the y-intercept might be a little more complicated, or not, we're going to see. But if I plug in 0 for y, one thing I can do is I can bring that 8 over, trying to isolate the x as much as possible. So I bring that 8 over. I can also divide both sides by -2 so that I get positive 4 is equal to log subscript 3 x plus 1. Then I can use my rules of exponents. I can go 3 to the power of 4 equals x plus 1. And what that does is it gets rid of the log and puts it in exponential form. And it looks like my x-intercept here is going to be 80, which is a little ridiculous. This is not going to fit on our graph, but it can give us some sort of an idea. We know that the x-intercept is way over here somewhere, okay? So we can just expect that the graph is going to cross the x-axis somewhere along the line. And the y-intercept, the reason why I left that out is because we can't really calculate the y-intercept right now, all right? Notice here, okay, well, we already have, sorry. Okay, it was actually the key point, which is 0, 8. But let me just do the calculations for you anyway, just in case you didn't notice that. Okay, what I have right here is I have to plug in 0 for x, and if I do that, I get y is equal to the log 3 of 1 plus 8, and I have to evaluate this log on its own first. Now, if you remember from one of the first days in the log unit in 12a, that would be an answer of 0. You have to say to yourself, 3 to the power of what number is equal to 1? And of course, anything to the power of 0 is equal to 1. So what we can do here is we can just say y is equal to -2 times 0 plus 8, And of course, that would give us an answer of 8. And we already have that graphed, so let's get to our domain and our range. Now, the exponential functions, the domain was always all real numbers. Well, vice versa, because they're inverses, all of the log functions, ln included, the range will always be all real numbers. So we only really need to think about the domain, and we can see right here that the domain on the very left side, it starts at -1, but doesn't touch -1, so it's a round bracket, and on the right side, it goes off to infinity. And away we go. Next up, we're going to try a natural log, an ln question.